Assalamu alaikum students, let's start the MCQs of alkyl halide. First MCQ is, in secondary alkyl halide, the secondary carbon is bonded to one hydrogen atom. Like look at here, this is the secondary alkyl halide, okay, and this one is the secondary carbon, okay. This carbon is bonded to one hydrogen atom, so option A is correct here. Among the following, more volatile one is, so the more volatile one is methyl chloride, okay. Like we know that in the boiling point of methyl chloride is lower as compared to the others, okay. So this one is the more volatile one, okay. Highest boiling point of the following is of. Now look at here, this is methyl chloride, ethyl chloride, N-propyl chloride and isopropyl chloride. Now we know that when the branching increases, what happens? The boiling point decreases, so option D is incorrect here, okay. Option D has lower boiling point. Now let's see these three. As the number of carbon atom increases, then in that case the boiling point also increases, so N-propyl chloride has the highest boiling point, okay, and it has no branching, that's why it has the highest boiling point. And look at here, methyl chloride has the lowest boiling point in these, okay. Base and a nucleophile are differentiated by their actions. So a base is the one which always attack on the hydrogen atom and it favors the elimination reaction, while nucleophile attack on the positive carbon atom, okay, positive charge carbon atom. So in this case the substitution reaction occur, okay. So look at the option C, a base attack on hydrogen in the elimination reaction, so option C is correct here, okay. When it attack on hydrogen, it detached the hydrogen atom from the carbon, okay, so it favors the elimination reaction. The stability of carbocation is in the following order. So greater the alkyl group, greater will be the stability, okay. Now look at here, option A is the correct one, okay. Like there is 3 alkyl group, there is 2 and here is 1 alkyl group. So greater the alkyl group, greater will be the stability, okay, because alkyl group is the electron donating group, okay. So in this case it stabilizes the positive charge of the carbon, okay. So we can say that option A is the correct order for the stability of carbocation. 6. Which alkyl halide undergoes the elimination reaction easily? So here option C is correct, okay. Tertiary alkyl halide undergoes the elimination reaction because these alkyl groups can stabilize this carbon, okay. So it can easily be removed. This halogen atom can be easily removed. Like if we remove this one, so we will get the carbocation, okay, positive charge, and these alkyl group are the electron donating group, okay. So they stabilizes its positive charge, that's why it can easily undergo the elimination reaction, okay. And look at the primary and secondary alkyl halide. After the elimination, when the halogen atom is leaving, when halogen atom is separated from this one, okay, primary alkyl halide and secondary alkyl halide, then in this case its stability is less as compared to tertiary alkyl halide, that's why it is not easy for these two to let go the halogen atom, okay. So easily undergoes the elimination reaction is this one, tertiary alkyl halide. All bases are nucleophiles. Their strength decided the type of reaction, either to be elimination or substitution. A weak base favors. Now let me tell you that a base always attack on the hydrogen, okay. But now in case of weak base, what happen? This weak base don't have such an ability to attract the hydrogen atom toward itself, or it don't have such a power to separate the hydrogen atom from the carbon and react with the hydrogen atom. So finally a weak base attached to the carbon atom and then it acts as a nucleophile, okay, and substitution reaction occur in this case. So when a base is stronger, what happen? The elimination reaction occur as it attack on the hydrogen atom and separate the hydrogen atom from carbon, okay. When a base is weak, then in that case they don't have such an ability to detach the hydrogen atom, so in this case they attach themselves to the carbon and in that case the substitution reaction occur, okay. Now if you want to make this easy, let me tell you that a weak base will always act as a stronger nucleophile. Okay, like when a base is weak, so they are unable to perform the elimination reaction, so in turn they act as a nucleophile and substitution reaction happens. A tertiary alkyl halide is reacted with KOH, potassium hydroxide, in water. The type of reaction will be option A is SN2, SN1 and E2 and E1. So we know that when tertiary alkyl halide react with KOH, so in this case this hydroxyl ion act as a nucleophile, okay, so SN1 reaction occur, okay, tertiary alkyl halide give the SN1 reaction. Option B is correct. Which one is Grignard reagent? So we know that in Grignard reagent our metal group and halogen is present, so option C is correct. Methyl magnesium bromide, option C. Tetraethyllead is organometallic compound, option D. Look, when the organic compound attached with a metal, so it gives the organometallic compound, okay, and when halogen is attached to this one, so it gives the Grignard reagent. Which Grignard reagent can be easily prepared? So look at here, option D is correct, okay. Methyl magnesium iodide can be easily prepared because which one is easily prepared? So greater the size of halogen atom, easily will be the Grignard reagent. Option A is correct. The treatment of Grignard reagent with propene produces alkane, okay, option B is correct here. In RMGX, the bond between the magnesium and halogen is more ionic, okay, option C is correct because halogen is electronegative and magnesium is electropositive in nature, so its bond is ionic. Which one of the following species readily react with Grignard reagent? So the species which readily react with Grignard reagent is Ri, okay. Which one of the following compound does not form alcohol on reaction with Grignard reagent? Here we know that formaldehyde give the primary alcohol, acetaldehyde give the secondary alcohol, acetone give the tertiary alcohol, and here carbon dioxide do not give alcohol on reaction with Grignard reagent. Carbon dioxide give the carboxylic acid, so option D is correct here. Carbon dioxide give the carboxylic. 17. Which one of the following can be used as Grignard reagent? So look at here, the first one is RMGX and the second and the third one are the benzene group attached with magnesium and chlorine, okay, so they all can be used as a Grignard reagent, okay, because in Grignard reagent either alkyl group is attached or benzene group is attached, they will act as Grignard reagent. Which one of the following would not be a reasonable nucleophile in SN2 reaction? Now look at the option A. This one is electrophile, okay, because it has a positive charge, so it means that this one is in search of the electron, okay, so this one is not a nucleophile, okay, option A is correct, not a nucleophile, so this one is electrophile, okay. Which of the following halide will react most rapidly in SN2 reaction? So here option D is correct, okay, because iodine is a good leaving group, okay, so it can easily leave the alkyl group and it can perform the SN2 reaction easily. The following mechanism represents. Now look at here, in the reactant side, look, in the reactant side, look, two reactants are given, so it means that this one will give SN2 reaction. And look at here, substitution has occurred, okay, so this one give SN2 reaction. Two reactant is present and substitution has occurred. N-propyl bromide on treating with alcoholic KOH produces a gas which decolorizes the bromine water but does not react with ammoniacal silver nitrate solution. The gas is now look at here, this one is the N-propyl bromide, okay, so when we react with KOH alcoholic, so this bond will be converted into pi bond. Okay, hydrohalogenation will occur. This halogen will be removed and hydrogen will be removed from here. Okay, so in this case what happen, this single bond will be converted into double bond. Okay, so it will give propene, and we know that propene do not react with ammonical silver nitrate, only propine react with ammonical silver nitrate. Okay, the terminal alkyne react with ammonical silver nitrate solution. So here option B is correct. Okay, and it do not react with ammonical silver nitrate. Reaction of methyl bromide with aqueous sodium hydroxide involved. So when methyl bromide is reacted with NaOH, so it will give the SN2 mechanism. Okay, SN2 reaction will occur because primary alkyl halide undergoes the SN2 mechanism. Which of the following compound will react faster in SN1 reaction? So we know that in SN1 reaction the tertiary alkyl halide react faster. So option B here, this one will react faster. Okay, mechanistically the below reaction will complete by, now look at here, this is tertiary alkyl halide and nucleophile is present, so we can say that the tertiary alkyl halide undergoes the SN1 reaction. Okay, so in this case it will unimolecular substitution reaction. Option C is correct here. Okay, which one has high boiling point? Now greater the branching, lower will be the boiling point. Let's see that boiling point is inversely proportional to the branching. Okay, when the branching is less, the boiling point will be higher, so option A is correct here. Okay, tertiary amine have low boiling point than the primary and secondary, because now I have told you that boiling point is inversely proportional to branching, but it's a short trick for memorizing that whether which one has higher and which one has low boiling point. The main reason is that tertiary amine have no hydrogen bond. Okay, they don't have hydrogen atom, so they couldn't make the hydrogen bonding. So option C is correct here. Look, this one is the tertiary amine. Okay, they don't have the hydrogen atom, so it cannot make the hydrogen bonding. That's why they have low boiling point. In the following primary amines, which one is more basic? Now which of the following primary amine is more basic? Now greater the number of alkyl groups, so greater will be the acidity. Okay, so in this case the primary butyl amine is more acidic as compared to primary propyl, primary ethyl and primary methyl. Okay, so greater the number of alkyl group, greater will be the basicity. Okay, because alkyl are the electron donating group. Okay, that's why it increases the negative charge on the nitrogen, so in this case the nitrogen has a greater ability to accept a proton. Okay, so it has a greater basicity. All of the following can be reduced to primary amine except, so NH3 cannot be reduced to primary amine. Like reduction involves the gain of hydrogen. Okay, when the NH3 gain the hydrogen, so it will be NH4 positive and it is not the primary amine. Okay, and reduction of these three will give the primary amine, so option A do not give the primary amine. Primary amine react with aldehyde and ketone and produce amine called shift bases. They are generally represented by, so the shift bases are amine is represented by Rn double bond Cr2. Okay, option B is correct here. An alkyl halide react with alcoholic ammonia in seal tube. The product form is, so when the alkyl halide react with ammonia, so it can form the primary amine, secondary amine and tertiary amine, so option D is correct. Okay, and this reaction can form all the three amines. The maximum number of molecule of alkyl halide react with a molecule of amine. So when first molecule will replace this one H, the second one will replace the another hydrogen. Okay, so and what will happen, the third one will come and attach with the lone pair of the nitrogen. So in this case primary, secondary, tertiary and quaternary amine will form. Okay, so maximum number is 3. Option D is correct. Following is the substitution reaction in which Cl replaces the Cl. Look, RCl is here and KCl. This Cn has replaced the chlorine and here it make the KCl and RCl. To obtain 1 propane nitrile, RCl should be. So look at here, RCl should be the chloroethane, because like this R has 2 carbon atom, okay, and when this another carbon is combined, so it gives 3 carbon compound, and we can get 1 propane nitrile, okay. So when chloroethane react with KCN, it will give 1 propane nitrile. So option B is correct here, okay. You have to count the carbon of nitrile also, okay. One of the following is incorrect statement regarding the elimination reaction. In the first step, carbonium ion may be formed. Now this one is the correct one, because in E1 reaction, the first step the carbonium ion formed. It may be a 2-step process. Yes, this one is also correct, because E1 is a 2-step process. It may be 1 step. This one is also correct, because the E2 is 1-step process, okay. And D, the product form is a saturated compound. This one is incorrect, okay. Look, the incorrect statement is D, because in elimination reaction the sigma bonds are broken down and the pi bonds are formed, which means that the unsaturated product is formed on elimination. So option D is the suitable option for this one. Which one of the following bond has the highest bond energy? Now this CF has the highest bond energy because they are most electronegative, okay, and also their bond length is less as compared to the others, so that's why it has a greater bond energy, okay. So option A is correct here. Which one of the following is the best nucleophile? Now look at here, iodine is the best nucleophile. Nucleophile is the one that has a negative charge and that are in search of some positive charge, okay. Let's suppose iodine has got the negative charge, okay, so the size of iodine is greater, so it will be very easy for iodine to share it with other atom or with other positive, okay, or it will be easy to leave this negative charge, okay. So we can say that iodine is the best nucleophile. Which one of the following is not a nucleophile? Now look at here, this option A is the electrophile, okay, because it is in search of negative charge. And look, NH3 is also a nucleophile because it has the lone pair of electron and it can donate this lone pair to other positive charge species, okay, that's why it's as a nucleophile. During SN2 mechanism, the nucleophile attack on the substrate before the C and X bond is broken. We know that SN2 mechanism is a 1-step process, okay, and in that case the bond breaking and the bond formation occur simultaneously, okay. So the nucleophile attack before the C and X bond broken. Option B is correct. In the first step of SN1 reaction, the hybridization of carbon changes from. Now look at here, this one is a tertiary alkyl halide. Before the SN1 reaction, what happened? This is sp3 hybridized, and when the bond is broken down, what happened? It is sp2 hybridized, like lone pair plus bond pair. Using that formula, so lone pair is equal to 0 plus bond pair is equal to 3, so 3 will give sp2, okay. So here the option B is correct. What is the order of kinetics in SN1 reaction? So if SN1 reaction is the first order reaction, okay, because only one reactant is involved in the slow step process. In elimination reaction of alkyl halide, the more susceptible side of attack is. Now we know that in case of elimination, the hydrogen is removed, okay, like for elimination we use base and base attack on the hydrogen, okay. So we can say that it attack on beta hydrogen, not the carbon atom. Option D is correct here. Alkyl halide are very reactive toward the nucleophilic attack because they are ionic in nature. This one is incorrect, okay. They are covalent in nature. The CX bond is non-polar, okay. This bond is polar, so this one is incorrect. They have nucleophilic carbon and a bad leaving group. So this one statement is also incorrect because it has a good leaving group, okay. And the other thing is that they have the electrophile carbon, okay. Positive charge is present on carbon, so they are electrophile. Look at the D option. They have electrophilic carbon and a good leaving group, so this one is the correct, okay. Option. Which amine react with acid chloride or acid anhydride to produce N and di substituted amine? So primary amine produce N substituted amine, okay, and the secondary amine produce the N di-substituted amide. So option B is the correct. This reaction is given in your book, okay, you can see here on page 214, okay. Dash amine does not react with hydrogen acid halide, okay. So tertiary amine do not react with acid halide because they don't have hydrogen atom to react with, okay. So option A is correct here. Primary amine react with nitrous acid and produce diazonium salt. This salt can generally be represented by R triple bond NN positive and X. Option C is correct, okay. They can generally be represented by this one. The reaction of RmCH3MgI with acetone followed by hydrolysis give. Now we know that acetone give the tertiary alcohol, so option A is correct here, okay. The electron deficient species are classified as electrophile, electron loving, okay, and electron sufficient species are nucleophile and bases. So here option B is correct. 48. RCH2X is an example of primary alkyl halide. Option A is correct, okay. Next one. The carbon atom carrying positive charge and attached to the 3 other atom or group is called carbonium ion. Option A is correct, okay. The Grignard reagent can be represented by a general formula of RMgX. Option A is correct, okay. This is the Grignard reagent. The end product of the reaction of Grignard reagent with ethyl acetate. Now with ethyl format it gives secondary alcohol, and with ethyl acetate it gives the tertiary alcohol, okay. So look at here, option C is correct, okay. Electron pair donor is classified as Lewis base, okay. In Lewis base we says that electron pair donor is Lewis base and electron pair acceptor is Lewis acid, okay. So here option B is correct.